Here we want to find the limit as x approaches infinity of the function the square root of x squared plus ax minus the square root of x squared plus bx. So let's go ahead and write that out. So we have the limit as x approaches infinity of the function the square root of x squared plus ax minus the square root of x squared plus bx. Now the first thing that we want to do is we want to get rid of the radicals. In order to do that, we need to multiply by its conjugate. So in the numerator, we have the square root of, again, x squared plus ax minus the square root of x squared plus bx all over 1. And so we want to multiply by its conjugate. And so the conjugate is the square root of x squared plus ax plus the square root of x squared plus bx, and the same thing in the denominator. Square root of a squared plus ax plus the square root of a squared plus bx. So now let's go ahead and multiply. So we have the limit, again, as x approaches infinity. Now when we multiply these two together, this is the difference of squares. So when we multiply them together, we're multiplying a radical times another radical, which means that we're going to get rid of the radical sign, and we end up with x squared plus ax in the numerator, and then minus, don't forget the parentheses, we have the square root of x squared plus bx times the square root of x squared plus bx. So we have x squared plus bx divided by the square root of x squared plus ax plus the square root of x squared plus bx, because we're multiplying that by 1. Okay, now if we distribute the sign to both of these terms, then what do we have left in our numerator in the next step? We have the limit as x approaches infinity. So what happens is that we get x squared minus x squared, and therefore what's left in the numerator is ax minus bx divided by the square root of x squared plus ax plus the square root of x squared plus bx. Okay, now our goal next is that we want to apply the limit as x approaches infinity. So in the numerator and the denominator, we want to multiply by 1 over x. So in the numerator, we're going to multiply that by 1 over x. And then in the denominator, we're going to multiply these terms by 1 over the square root of x squared. Okay, so again, I want to point out that 1 over x squared is equal to 1 over the square root of x squared. Because if we simplified the square root of x squared, then that gives us 1 over x. And so the reason why that we're writing it in this way is because these mean the same thing, but we have the square root in our denominator, so it's going to allow us to be able to divide each of these terms with an x squared so it has a radical underneath it. So what that means now, and again, that's just all algebra, so we have the limit as x approaches infinity. So we have ax divided by x minus bx divided by x all over, we have the square root of x squared over x squared plus ax over x squared plus over here we have x squared divided by x squared plus bx divided by x squared. So now let's go ahead and simplify. So now when we simplify according to x, then we end up getting the limit as x approaches infinity. That x and x, so we're left with a minus b in the numerator because we see that, get that. And then we can also see that x squared divided by x squared leaves us with 1 plus, we can divide out the x, so that's going to leave us with a over x, plus we have x squared divided by x squared, which is 1, plus b over x. Now a and b we assume are constants. So now what we want to do is we want to find a limit as x approaches infinity. So if a and b are constants, so what we have left in the numerator is a minus b. And then we see that a over infinity here is going to give us 0, and b over infinity is going to give us 0, and the ones are going to stay the same because those are constants. So we end up having the square root of 1 plus the square root of 1. Well, that becomes a minus b over 1 plus 1, which is equal to a minus b over 2.